Today we are going to see the maximum speed of a vehicle. Speed of a vehicle along rough banked road, that is considering friction with banking, considering force of friction along with banking. This is our today's article. Suppose this is the horizontal and suppose this is the banked road. Theta angle of banking. Suppose you consider this is the vehicle moving on a rough and banked road. This is the curvature. Now different forces on this vehicle are shown like this. Suppose N is normal reaction, weight mg in downward direction. Now also we consider another force, Fs, force of friction, that is force between tires of vehicle and road surface. Now N can be resolved into two components. Suppose this angle is also theta, then N cos theta and N sin theta. These are the two components of N. N cos theta is vertical component, N sin theta is horizontal component. Also Fs is resolved into two components. This Fs cos theta, this is horizontal component, and we consider here Fs sin theta, this is the vertical component. All these are components. Now we will consider here weight mg, it acts in downward direction. Fs is force of friction, we resolve into Fs cos theta, horizontal component, and Fs sin theta, vertical component. Also N means normal reaction, it is resolved into N cos theta, vertical component, and N sin theta, horizontal component. Then from figure we can write here mg plus Fs sin theta. We add these two because both are in downward direction, which is equal to, this is balanced by N cos theta. And therefore we write here mg is equal to N cos theta minus Fs cos theta. Also Fs is equal to mu n. Mu is coefficient of friction, n is normal reaction. Therefore we write mg is equal to N cos theta minus mu n. Mu n, here we consider N cos theta minus Fs, we consider this is the sin theta, mu n sin theta. Suppose this is equation number 1. Now these two components, Fs cos theta and N sin theta, this produces necessary centripetal force. Therefore for this we can write here mv square upon r is equal to N sin theta plus Fs cos theta, which is equal to N sin theta plus mu n cos theta. Suppose this is equation number 2. Now dividing equation 2 by 1, we can write here mv square upon r divided by mg, which is equal to N sin theta plus mu n cos theta divided by n cos theta minus mu n sin theta. Here m gets cancelled and all these capital N gets cancelled, and therefore v square upon rg is equal to sin theta plus mu cos theta upon cos theta minus mu sin theta. Therefore v square upon rg is equal to, here we take cos theta from numerator as a common, then cos theta is equal to v square upon rg equal to cos theta into bracket. Here we write sin theta upon cos theta plus mu. Here denominator we take cos theta as a common, then we get here 1 minus mu tan theta, sin theta upon cos theta. Therefore v square upon rg is equal to, this cos theta gets cancelled, and therefore v square upon rg is equal to tan theta plus mu divided by 1 minus mu tan theta, and therefore v square is equal to rg into bracket tan theta plus mu divided by 1 minus mu tan theta, and therefore suppose v is equal to, or in the square root I write like this, mu plus tan theta upon 1 minus mu tan theta into rg, and this equation 3, this is the maximum safety speed for a vehicle in case of banked road and also considering the friction. Now this equation 3 can be converted in our earlier equations. That is, if we take friction is absent, suppose case 1 friction is absent means mu equal to 0, then equation 3 can be written like this, v equal to square root, here mu is 0, therefore tan theta into rg, tan theta into rg, and mu is 0, therefore we write 1, means v equal to root rg tan theta, only considering the friction. And case 2, if banking is absent means theta is equal to 0, then v equal to tan theta 0 means tan 0 0, means we write here square root of mu rg, and 1 minus 0, this means 1, we get this equation. That means this equation is combination of the two, that is considering frictional and also considering banking. And here we consider if friction is negligible means 0, then mu is equal to 0, then v equal to root rg tan theta, only banking is there, and when banking is absent means theta is equal to 0, then we get here v equal to root mu rg. This is all about maximum speed of a vehicle along rough and banked road, that is considering friction with banking. Now we will consider another article. Suppose another article we consider here, wall of well or wall of death. Well or wall of death. Here suppose you consider, this is the diagram. Suppose my motorcyclist in a circus moves on this track. Here, motorcyclist moves on the track. Suppose this C, this is the center. Now motorcyclist is here. We consider here. Motorcyclist is here. Now we consider three forces. mg, weight, which acts in downward direction. Fs, force of friction, which acts in upward direction. And n means normal reaction, which is in horizontal direction. Here forces are: n means normal reaction, mg, weight, vertically downward, Fs, force of friction, vertically upward. N is resultant centripetal force. We write here. N is resultant centripetal force. Centripetal force is equal to N. We write here mr omega square is equal to mv square upon r. This is necessary centripetal force. And mg is equal to, we write mg is equal to Fs from diagram. Fs is always less than or equal to mu s into n. Therefore, I write here Fs less than or equal to mu s into n, and therefore I write mg less than or equal to mu s into mv square upon r. Therefore, g is less than or equal to mu s into v square upon r, and therefore v square is greater than or equal to rg upon mu s, and therefore v minimum is equal to square root of rg upon mu s, and this is the minimum speed. Below this speed, that vehicle skids in downward direction. This is well on wall of death. We formally see in the circus. Thank you.